Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of preliminaries of Algebra. In that we have already discussed quite a few things. Okay, now in today's class we will start the topic of logarithms. Alright, now in this topic first I'll give you the theory of it. Okay, then I'll take some examples and make sure that you understand, you get this concept well. So let me start with the definition for a change. Okay, let b greater than 1, understand, this quantity must be greater than 1. Okay, be a real number. Then we say logarithm of x to base b is y. Understand the sentence, logarithm of x, there is a base, so to the base b is equal to y if b to the power y is equal to x. So to understand this clearly, you have this thing. Okay, so how do you write this logarithm of x to the base b? Okay, so you write logarithm of x to the base b. This is the way you write it. Okay, now understand, when logarithm of x will be equal to y, only if b to the power y is equal to x. Now what is this? Base for the exponential, and what is this? Base for the logarithm. They will be same. Okay, only these will switch their places. See, this y will come as the power to the base b, so y will be the power to the base b, and this x will be independent. So basically what you understand here is, I want to find this power. I have this expression, I want to find the power, what is the value of y, so that I get x. Okay, what is the value of y? Okay, so that b to the power y is equal to x. Now if you want to find this y, what you need to do is, you have to find the log of x to the base b. So this is basically to find this quantity, to find the quantity. So exponential and logarithms are interchangeable, they can convert to each other. Okay, so they are like a pair. Okay, they are always together. So if you want to solve a problem on logarithm, you should be able to convert it to exponential and see which one is easier. Okay, so some problems on logarithm can be solved using the exponential concept. Some problems on exponential concepts can be solved using taking log. Okay, so they are always together, so keep that in mind. Okay, and always keep this conversion in mind. Okay, so this interchanging properties must be known to you. Well, we will solve a few properties, formulas of logarithm, but before that let us understand the logarithmic function. As a function, how do you define this log? Okay, so logarithm is a function, just like you have constant function, identity function, signum, greatest integer, and all those things. Okay, so now what you mean by logarithmic function and how do you define it? Okay, so this is defined by log, just like f of f from r to r or something like that. Okay, so what is the function here? Log to the base b, and that is from r plus. I'll explain why this is r plus and not r. Okay, so positive real numbers only. So domain of log is only positive real numbers. So log will take the values only from the set of positive real numbers. So log cannot take a negative number here. Log cannot take a negative number here. X cannot be negative at all. Okay, so keep that also in mind. Second point I am telling you. Now r plus 2r, the output will always be a real number, any real number. Okay, positive or negative. Now look at this. You have taken a number from positive real numbers. Okay, so x when it goes through this function, what does it become? Okay, so you have x here. All right, so these are only positive real numbers. Okay, you have only positive real numbers, and these are any real numbers. So what happens when it comes here? That y becomes log to the base x. So this function is log to the base b. Okay, so this is the arrow diagram representation. So understand this. What point you must take home is this: you can put only positive real numbers in place of x, in place of x. So domain of log is always r plus. Okay, you can have the values only from r plus as the values of x. So that point must be kept in mind, and this conversion you know already well. Now let us take some examples to understand this better. Okay, now you know that 4 square is 16, a simple example. Now this can be represented as log base, log to the base 4, 16 is equal to 2. Okay, so this is how you convert from log exponential to logarithm. So understand, log 16 to the base 4 is 2. Okay, so that is because we can convert to exponential and see the verification there. All right, now you know that 10 cube is 1000, correct? Okay, so 10 cube. Now what is log 1000 to the base 10? So you have 3 zeros, therefore this is 3. You might have learnt that in physics or chemistry, correct? Okay, so log to the base 10, log 1000 to the base 10 is 3, because 10 cube is 1000. Right, now if you do not know this, you can find it. See, for example, you take it as x. So what is the value of x now? So x is nothing but log 1000 to the base 10, and what is it? 3. Therefore x is equal to 3. So if you do not know the power here, you do not know the index here, you can always find using the log concept. That's the basically application of log. All right, so I hope this makes sense. So you want, if you need one more example, say 5 to the power 4, right? So what is 5 into 5 into 5 into 5? You have 625. Now convert this to log. How does it look? So 4 is equal to log of 625 to the base 5. So log 625 to the base 5 is 4. Similarly, you know 25 square is also 625, correct? Now how does it look? So 2 is equal to log 625 to the base 25, So look at this. If the base changes, then log of 625 also will change, correct? So even the bases have a role to play here. Base is just not just a number there. It has something to do there. What is it? That is the base for the exponential. Okay, so if the base changes, automatically you will have a different power here. So if this is 5, then you have the power 4. If this is 25, then you have the index 2 here, power 2 here, correct? Okay, so remember, this is not just a number, you can't ignore this number. So that's the third point I'm telling you. Okay, don't ignore this number. This number also plays an important role in logarithms. All right, so basically what you must understand from this definition is this conversion, okay. So base remains the same, these numbers, okay, this number will come as the power here and this will be independent, okay. So this will be independent. If you know the value of y, you can always find x using this. If you know y, if you know b, base, you can always find the value x, correct? Okay, so if you do not know y, then you can find that y using log. So that is the beauty of this exponential and log. You can convert to each other and see which gives you the better results. Okay, so depending on your problem, depending on your situation, you can select either exponential or log method. All right, so next we will solve the properties. We will understand the properties of this log and we will understand thoroughly, because this knowledge is very important for all the next chapters that are going to come. Okay, you may have this logarithm coming in differentiation, you have this log coming in integration, differential equations. So everywhere you need this knowledge of log. In competitive, in JEE main questions, you will definitely get log in some or other chapter. Well, so let's start with the property.
Don't forget to like our video and subscribe our YouTube channel for all the updates.